Hello everyone. In this video, we will try to learn about feature and feature collection from the guides available from earthengine. earthengine API has different objects and methods. Objects in earthengine belongs to different object classes. Features and feature collections are the types of earthengine object classes along with the different other object classes. Objects and methods act as the combined workflow scripts for helping us or for helping the earthengine servers for processing. We, in this video, are trying to cover all the guide sections related to features and feature collections. These codes and all the other informations are available from this link. And we will be covering about feature overview, overview about feature and feature collection, something about feature license, and getting about or further knowing about feature collection information and metadata. We will be filtering a feature collection, mapping for feature collection, and something related to reducing a feature collection. So to define the feature is an object with a geometry property. It has the geometry object and the properties with it. Here in the very first few codes here, we have a polygon, a variable named polygon, created by ee.geometry.polygon. We are saying this you're seeing this message because we can convert it so that it appears at the very top. It's the same thing. And that geometry has been created as a feature from ee.feature. And we have here some properties added along with it inside the curly bracket. We can print the feature, and that feature can be added as a layer. So when we run this, so here we have the feature, and the type is feature, and we have geometry. The geometry type is polygon. We have coordinates. We have the 5 different coordinates starting from 0, and it has some properties that we assigned it earlier. And here we have the second example. So the dictionary has been created here, and it has some properties with it, and it is to show that the feature does not need to have any geometry to call it a feature. So even a null geometry feature can be considered as a feature. So this is such an example. And here we have a feature, and we try to learn how to add properties to a feature. So feature can be added with properties by .set here. And here we have the properties added by .sets, 2 different properties. And we can get the properties by .get and select what properties we want to get from that feature. And we also have, we can also set the new properties here, and we can certainly set the new properties to the previously old features. For example, here we have the new dictionary, and that has been added as a new properties, or we have overwritten it by .set. And we can print the feature. So here, as an example, we can be aware that properties can be set with key and value pair, like here, like this, inside the single quotes, or as the dictionary form as well. We can assign the properties like this as well inside the curly brackets. So these are the 2 ways of assigning the properties. So when we run this, we get things in console. Here we got the single ingredients. It's just the we got these properties by getting it, and we have different features here. that we had overwritten earlier. So this was a very quick guide related to the feature. We learned a few things about feature, and let's begin about feature collection. So feature collection is the group or combination of the feature. This is important because additional operations can be done in the feature collection. We can filter, we can sort and render. So different operations can be done in the whole feature, in the whole features, not just in a single feature. So here in the very first code here, we have the variable named features, and we have here 3 different features. The first contains a rectangle, the second contains the point, and the third contains the total contains the point, and there has some properties along with it. So it's I believe it is the name of the places. So this is the list here, and this list has been converted, or a feature collection has been created from e.feature collection and from the list of feature here. So when we run this, we get the from list, and here we have the type as feature collection. We have columns, some properties associated with it. We have features here, 3 different features, and these 3 features has created the feature collection. And not only from different other polygons or different more than 1 or 2 points, even a single point can be considered as a feature collection. Here we have just a single point, and this can also be created as a feature collection. So here this is a type feature collection. So here we have the table dataset, and this table dataset can also be added as the layer here. And this is to show, this is an example that even the feature collection has been added as the layer. And here we have the ways to generate the random points. So here we have the region selected, that is the rectangle, and our random points has been created with the dot random points inside this region, and we center these random points at the center of the map by dot center object, and that is added as the layer. So if we run this, we get some points here. We get some points here. So here we have the points. We also have the nice example. This is from the guide section, or from the community section here. So what we have done here is we have variable named geometry. This is somewhere in the USA, state named USA, and a polygon. This is a polygon somewhere hit there. And inside that polygon, we are creating the random points by dot random points. And we want to have the 25 random points in them. And this 12 number 12 represents the seeds value. It comes as the start point from where the random number sequence will be generated. It is to make sure that the random numbers will appear again and again. It's just for the repeatability. Similarly, we have another random points, 25 random points, and here the seed value is 1, and we merge them by dot merge. These 2 feature collections can be merged. We can set them some center here to appear at the very in the middle section of the map, and we add them as layer, and different properties has been provided. The first one is red, blue, and here we don't have anything. It appears something gray, and here we are printing the variables, and it's we can be sure that it's an efficient way to print the variables. We can in a single row we have 3 different variables, and we can print them. Just a quicker way to do it. So when we run this, we get this here, the red and blue. So the first feature is the new feature here, and then more new features and combined feature collection. This is the blue one. This is the combined one. And this was to show that random points can be created and they can be merged. Just an example. So that was the example. So here, let us comment this again. So now we move to the feature and feature collection visualization. So it is no doubt that that even the feature collection can also be added as the layer. So here we uncomment. So this is the comment. It should be commented. Okay. So here we have the variable and regions. We have some feature collection assigned to this variable, and we want to display it as the layer. And we also have some colors assigned, and some stroke white is something related to the outer boundaries. We want to have some thickness to it, and the other one is point radius, that is for the point. So this is just the assigning to the visualization. So if you run this, so we get somewhere like this. So the first one is the default display. So here it appears whenever we do this, like there's nothing inside the color bracket, it appears as gray. It's the default one, but here we have the second one assigned as the color, and this appears as red. This hexadecimal value is for the red color, and the third one is drawn, and inside this we have not only the colors but also the thickness to the to the outer boundaries, so it appears a little thicker than before. And for additional display, we also can paint. We also can add some other properties with it. So the very first one is here. We have some created an empty image in which the features will be painted, and here we have dot paint, and here we are working with the edges here. And in the second one here we are adding some colors palettes. This is something to make more appealing, and we have some white parameter, and it says some different color white edges, and we also have some more pins here. For example, here we are doing dot pin 2 times. So these are just the showing, just to show that different colors can be placed, or different things can be done with the feature collection for the visualization. So if you run them all, we can check them one by one. So if we untick them all, so this was the default display, we did it before. It has nothing inside it. So then we had the colored one, that was the red one, and we had the green one with some thickness in the boundaries, and then we worked with dot paint, and dot paint has something more visualizing. It's painting inside, so it's painting one of the edges here. It is appearing as red, and we have different color edges. For different color edges, we have 3 different colors, and we are working this with the outlines. For example, here is red, blue, and green. And also there is something with different color and white edges, different colors, and the outer boundaries, or some thickness with the outer boundaries, is being changed. Similarly, we have colored fills. Now here we are filling them with the colors. And finally, we have edges and fills. So here we are having a different edge colors and different fill colors. So this example demonstrated that different things can be done with the feature collection. We should want to explore them more and try them more. So let us comment this again. And now we move to feature collection information and metadata. So feature collection can have metadata, and from the feature collection, we can also do what similar things are done with the image collection. So let us uncomment the first one here. So here we have some feature collection added into the variable name sets. We are filtering it only to the USA by dot filter bounds. We have some region here that is rectangle, and we want to get the square kilometer, and that string values is changed to the number by ee.number.parse, and that is received by this function. So that is what we are doing here. So we have the first to extract the first water set, and we want them to print it. We want them to print it, and then we also want to have the number of water sets printed by dot size, and some here statical properties, statical calculations done with by dot aggregate underscore stats. So this demonstrates how the features collection can have their metadata selected. And here we have the second example. So we want to comment them. So here we have the next example. So in this example, what we're doing is the selection of one of the columns, and we have here function, and it only selects the columns. And here something is happening with dot evaluate, and in this is the particular case where the extracted feature collections are received as the dictionary, with column names as keys and values as data types. So when we run this here, so here we have the visualization. Something appeared as layer because we had added this as layer here, and we have printed the sets.size. So it appeared as 336. We have some area statics here, maximum, minimum, and things, other things. And we also have the object that we printed it. This is the column, I believe. And so this was something related to the extraction of information and metadata from the feature collection. So these here are the helpful examples. So now we move to the filtering a feature collection. So filtering a feature collection is something similar to the image collection. Let us uncomment them all. Okay, what we are doing here in this example is we are repeating what we did earlier. We are getting the area as in square kilometer. We are converting that to the number by ee.number_parse, and we are returning this as the number. This is the whole function here, and this has been added to it by dot map. So even in a single chunk of code, the function is created, and the function is working by with the function is mapped. That means function gets to go, and we want to have some reasons, and we want to have the table selected only by those reason, that is content US variable. And we also have some feature of number of water sets selected for for a location. And here we have something dot greater than. So filtering can also be done by dot greater than and some values, and each number can be checked. And finally, we want to check the number of water sets. So how many water sets has been selected by this dot gt, what we did earlier by dot size. This is a filtering in a feature collection just by using the dot greater than. So this was the example of filtering a feature collection. We just created a function. We want to get the areas in square kilometer, and we wanted to have those bounded by some region, specifically the continental US, and we wanted to know what was earlier in the original table, and then after we wanted to specify something greater than that, and we want to know how many was resulted to count after. So we wanted to compare the two values here. So of course it's going to be a little smaller than this, so it's getting time. It's taking time. That's okay. So we have 140. So the value is 140, which is greater than 25,000. So this was about filtering a feature collection. We also have mapping over a feature collection. So let us uncomment them all. So here, we have a function to compute the features geometry area, and by dot set, we are adding as the property, and the function is mapped to the previous table, the first one sets, and the new properties are generated. So this function here, we have the previously assigned table here, and in that table we just created the new things added, new things created, and the feature is printed. So here we have this one, and here we have in the second example, here we have the function. It keeps the list of properties, and we want to have the centroid of the features geometry by dot centroid, and we want to return a new feature, and that function of the function has been mapped, and we display the result and add it as the layer. So here we are creating the new feature collection from the previously assigned feature collection. So if you run this, so in the first example, to summarize again, in the first example, we created a new new properties, and we assign it to the feature collection. And in the second example, we totally created the new feature collection from the previously feature collection. So that's the difference. So we are creating a new feature collection from the previous feature collection, and we are assigning, or we are getting the new properties within the feature collection. These two examples demonstrates them. That's it. And finally, we want to work on reducing a feature collection, and here let us uncomment them. So here we have the variable num sets. It has been bounded by the filter bounds. We want to have the feature collection only from those region, or the rectangle here. And here we are creating a function. And in this function, what we're doing here is we want to have computed two different areas computed. The first one is area in square kilometer directly from the geometry, and the second one is the area within it. So computed area of the properties within the feature collection. So two different areas, and that would be subtracted between each other. And from those subtracted areas, we want to have its squared calculated. We want to square that one, and after that square happens, we want to, here we have added that function here. We'll map that function. And after that calculation of the squared value, we want to calculate its mean. So all these things will have this squared power. Means will be calculated, and we get the mean, and that would be, we want to calculate the square root. So this is all working as a root mean square root of the mean square. So this is an example of reducing the whole feature collection. We subtracted two different areas. We get the power of 2. We want to square it. We mean it, and we get the square root of it, and we get the root mean square error. And in the second example, we have image of daily precipitation in millimeters per day. And similarly of water sets, we are bounding it by some area. And we want to calculate the mean of the image that has been added. And we want to have total rainfall calculated in cubic meters. And the function is mapped. And we want to sort them out by in a descending order, and only the top 5 will be listed out, and we want to get them as the list. So if you run this here, the first one was we calculated the root mean square error, and the second one was to find only those the top precipitation values, the highest precipitation values. It's taking time. So here we have the list of 5 elements. These are the descending from sorted the highest volume of water sets. So features and feature collections are very important. While it is similar to the image collections, feature collections can also have a very important role in the earthengine, and we really want to be fluent in feature collections as well. So these are, again, we have all taken it out from this link here. You can follow them there. So I hope this was a little helpful for you. So thank you for watching. So any comments are welcomed. I really want to thank you for watching this. Thank you again.